So, in the diagram, the line AB is a diameter because it goes through the center of the circle marked by O. Find the angles marked. So I should be able to find A first. I should trust my conviction on that. So there is my isosceles triangle again. A must be 50 degrees. What about B? So B is the remaining angle from this triangle here. So 50 degrees is 100. B must be 80 degrees. C next. Okay, now how is C related to what I've worked out before? It is a difficult one to spot this. If you haven't, I can understand it. Remember the theorem that says if you have a triangle subtending from a diameter, then you've got a 90 degrees in it. Now that means that the angle ACB is 90 degrees. And I've worked out A already, but this whole thing is 90 degrees. So 90 degrees minus 20 minus 50 is C. And that's 70 degrees. This must be 20 degrees. Now what about D? Spend a moment to think about how you can find that. And can you see that it swings? This angle here subtends from the chord BC, has swung all the way around to there. So this angle and this angle are equal because they both subtend from this chord here. This angle and this angle. So D must be 50 degrees. And finally E. For the same reason that we worked out that was 90 degrees, these two angles here must add up to 90 degrees. So that must mean that E is 40. Okay, now quickly working through the final example and I'll let you get on with the exercises. The chords A, B and C, D are parallel and that is shown with these two marks here. Prove that the triangles ABE and DEC are isosceles. So the triangles ABE is the small one here, and DEC is the larger one here. How are they both isosceles? That must mean that these two lengths are equal. And these two lengths must be equal, but they're different lengths, so I do it with the double dash. By looking at the fact that there are parallel lines in here, I need to use the alternate angle theorem. So that means this angle here is also A, because it's that Z thing, Z shape from before. Now what else can I show? In order for these to be isosceles, these two angles here must also be A. But how can I show that from this diagram? It's very difficult to spot this one. If I should draw the chord, the chord for a BC. Now you may spot that BAC subtends from the chord BC, and so does BDC. So that must mean that these angles are all the same. So that means that one and that one are also A. And hey, look, there we go. There's the isosceles triangle. Now, for the same reason that we showed using the Z angle, the alternate angle rule, if this one is A, then this one also must be A. And therefore, we have two isosceles triangles. Bang.